Okay, so the next question that we have here is a vector situation. Everything's fun with vectors. So the question is asking us, we're having trouble with this question. Okay, the question's here. So we have two vectors. We have A. So let me write out the vector A. I'll write the units outside of the brackets. This could be a nice thing to learn. So 2.4 I and plus 4.5 in the j direction, and that's all meters. And our second vector B is going to be, well, another two-dimensional vector, except it's going to be 4.1 in the I and negative 2.2 in the j. Okay, now we have to compute the following vector quantities. Okay, so A plus B. Well, we just have to add up these components. I terms go with the I terms, and the j terms come with the j terms. Okay, so A plus B. We see that it will be the I terms added together. So 2.4 plus 4.1, that's 6.5. And we're going to have a 4.5 plus negative 2.2. So that's going to be 2.3 plus 2.3 j meters. Okay, so those correspond good to those answers. Now the magnitude of AB, we represent it with like a double absolute value for magnitude. Sometimes you also see it with like a single absolute value. It's just sometimes we get confused with absolute values, so it's better to do double sometimes. But it's just like a Pythagoras theorem situation. 6.5 squared plus 2.3 squared, all under the root. And this shall give us under the root 6.5 squared plus 2.3 squared. It is 6.89. Yeah, good job. Meters. Okay, keep in mind that the units still got to persist, so the magnitude of this sum is meters. Now, the next thing that we want to keep in mind here is what is this actually representing? So if we're going like 6.5, 3, 4, 5, 6.5, 6.5 in the I direction, and then 2.3 in the j direction, like this, in the positive j direction, right? So it's going up. What we're pretty much looking for is this angle right here. So if we want to get this angle, we can see that it will take the inverse tan of 2.3 over 6.5. Okay, so this angle should give us inverse tan divide 6.5, 19 degrees from the positive x-axis. Okay, and yeah, we got the same answer here. So it's likely maybe it wasn't a tan that was used here, or maybe the maybe it was the other way around. Maybe it was reciprocal, but otherwise, like you generally want to like draw this out so you can kind of have a visual idea of what's going on here. Okay, so the second part of this question is asking for the vector b minus a. Okay, so if we want to do, maybe I'll do this in a different color just to show the separation, but it's a very similar procedure. So vector b minus vector a, we're just going to be doing those components individually. So, the I component minus the I component of I, so 4.1 minus 2.4 is 1.7. in the I direction, and in the j direction we're going to have 2.5 minus 4.5. Okay, so that's going to be negative 6.7. Yeah, exactly. And all in meters. Okay, and for the magnitude, let's just write magnitude. Well, we're going to follow the same Pythagoras theorem type of situation. So under the root, we have 1.7 squared plus 6.7 squared. I mean, you could write plus negative 6.7 squared, but the negative neutralizes itself on the squaring, so it's not really necessary. So let's ask our calculator what that is. Make sure that it's right. Okay, here we got 1.7 squared plus 6.7. And I got 6.9, same as you. Awesome. So this is equal to 6.91 meters. Happy face, we got the same answer. And for the angle, well, it's going to be the same procedure. It's going to be the j component divided by the I component in the inverse tan. Negative 6.7. Don't forget that negative, okay? 1.7. And, okay, so let's take that calculation ASAP fast. Negative 6.7 divide 1.7 is a negative 75.76 degrees. Now, does that correspond? Let me just check real fast if that is the same as, that is just slightly off from this number. It's like actually 284, but it's very, very close. So I'm not sure what procedure that this corresponded to when you calculated this, but very close, but maybe just like a rounding error or something like that going on. But otherwise, yeah, this solution here is good, and you know, hopefully we got the help that we needed. Cool. Both solution is good. Awesome.